All right, in this part, we are going to discuss about charges. Determining the force on a charge moving in a magnetic field. Since a moving charge produces a magnetic field, it should come as no surprise that a moving charge placed in an external magnetic field will feel a magnetic force because of the Paul law. So furthermore, a stationary charge in a magnetic field will feel no magnetic force because the charge will not have its own magnetic field. In fact, the force felt by a charge q traveling at velocity v through a magnetic field of strength b is given by F is equal to q vb sine theta, where F is the magnetic force, q is the charge, v is the velocity, b is the magnetic field. So that means that in order for a charge to have a magnetic field, it should have a charge. In order for a charge to have a magnetic force, it should have a charge and it is moving. So F basically is perpendicular to V and B. They are orthogonal to each other. When I say orthogonal, that means that they are forming 90 degrees against each other. Again, it should be 90 degrees or perpendicular towards each other. So you will have X, you have Y, and you have Z, just like what I've mentioned, positive Z and negative Z. The direction of F is given by another right-hand rule. So in this part, you will use this. Not this, okay? Not this, but this. I hope that here you can understand more onto the right-hand rule, even just for the video. The direction of F is given by another right-hand rule. Place the heel of your right. So here, this is going to be your this is okay. I'm not sure whether your extended thumb points in the direction of the force. Okay. Okay, I'm going to discuss this by this. There are many options on how to do this, but I'll stick onto my to how I'm used to, and also some of the books are using this. So the thumb is going to be the QV. Again, the thumb is going to be the charge. The index finger is going to be the magnetic field, and F will be the magnetic force. Again, they are perpendicular to each other. So that means that if I have X and Z here, I'm looking for the Y, but where is the Y? So for example, I have positive X. So here, this is my X. Okay, I hope that you are clear with this. This is my X. So my QV, which is my thumb, is my X. I'm going to edit this one. Sorry about that. This is going to be my middle finger. Thumb. And this is my index finger. Index finger is this one. Okay. So here, I'm going to have positive X, and this is going to be negative Z. Negative Z is into the page. Into the page. As you can see here, my thumb is going up. Okay, my thumb is going up because this is going up. So you can see here the right-hand rule. Again, I will repeat, I will have positive X here. This is my X, positive X, and then negative Z is into the page, which is my index finger. So into the page. Look at where my thumb is. My thumb is going up. So here, I will have positive Y. I will edit this one. Sorry about this. This is keeping, this is, where is my PPT? This is going to be positive Y. How about for this one? So I will have negative X here. So here is my negative X, and this is my negative Z. Negative Z is where? Negative Z is into the board. Okay, this is into the board. Look at where my middle finger is. Again, I will repeat it. This is my QV, and this is saying that it's at the negative X. And then afterwards, this is my index finger, which is negative Z. And where is my middle finger? My middle finger is going downward, so this is going to be negative Y. negative y. Okay, so how about for this one? So I'm looking for the where the Q is going. So magnetic field is negative x. So here is my index finger and it's going negative x. This is my negative x, and my middle finger is negative y. Okay, my middle finger is negative y. As you can see here, my thumb is going into me, which is out of the board. So this is going to be positive z. Positive z. All right. And for this one, my middle finger is negative x, and my QV is positive z. Okay, where is my positive z? So this is out of the board. So as you can see here, this is out of the board. Where is my index finger? My index finger is at upward, so this is going to be positive y. This is going to be positive y. I hope that by this time you already understand. However, if you're not sure, you're not really familiar, you can ask me about this. Okay, just like a summary for this right hand rule, we are using the curl if we have the current carrying wire. So the current carrying wire, okay, the thumb will point where the current is going, and then your middle finger, the the four fingers are actually going onto the curl or of the magnetic field. Okay, so it depends. It depends where it is. And then afterwards, for the solenoid, wherever the current is, you have to use your four fingers and then curl it where it is going, and then your thumb will go to the north-seeking magnetic field. So this is where the magnetic field is going. And then afterwards, you will use this right-hand rule also for QVB is equal to F, wherein this is the charge and where it's going. So this is the velocity, Q and V, and this is the magnetic field, and this is your middle finger is the magnetic force. So I hope that by now you are familiar with this, but then again, just like what I want to tell you, I please ask more questions. And if you are still here, thank you very much for watching.